Today we'll be looking at the distributive property and also using the distributive property in two different ways. One, to use to make mental math easier, as well as another way to simplify expressions. This is the first example. It says a group of 3 adults, an 11-year-old, and 2 children under 10 years old are going to a baseball game. If you look at the chart, you have an adult ticket costs $5, child 12 or under costs $3, groups of 10 or more cost $2, and a senior who would be 65 or over costs $3. And this is for each game, so a single game price. We need to write and evaluate an expression to determine the cost of the tickets for the whole group. And remember, the group consisted of three adults, an 11-year-old, and 2 children under 10. So, to determine an expression, we need to figure out how much each ticket costs. So, an adult, there's 3 adults. Each ticket costs $5. So, we would write 5 times 3. We're going to do the total, so we're going to add that to the price of an 11-year-old. An 11-year-old would be a child, because a child is considered 12 or under. So that would be $3. And there's only one 11-year-old. Then there's 2 children under 10. And children under 10 are also actually considered children. So we have 2 more children that are $3 each. So, we've written out our expression. Now we need to solve. Excuse me. We need to solve. You would solve by multiplying and then adding. So, 15 plus 3 plus 6. And then you could do 15 plus 3 plus 6 all together to get 18 plus 6, or $24. You can also use the distributive property to help make mental math easier. So say you had some very large numbers that are not easy to multiply in your head. You can think about breaking them up into a group of numbers that you can use the distributive property, and to complete it, you could do it in your head. So for example, 304 times 15. Well, I might want to break up the 304 into 300 plus 4, and group it together and leave the 15 where it is. That way you could see that we would use the distributive property, and I'd be doing this technically all in my head, to get my answer. My answer would be 4,560. You could also do it a different way and maybe break up 15 into 2 parts. Such as that. So 304 times 10 plus 5. And again, using the distributive property, we could do this more easily in our heads. And we should get the same answer. When you're doing the distributive property, notice that I've broken the numbers up using addition. In the parentheses with the distributive property, if you're breaking up a number and putting it in a group, like 300 plus 4 here, or 10 plus 5, the addition, or the operation that you can use is only addition and subtraction. You can't break up the number using multiplication and division. So let's try another one like that. Let's say 210 times 5. Now you try to break it up how you'd like to do it mentally and find your answer. Did you find it? I think if it were me, I would break up 210 into 200 plus 10 and keep the 5 how it is. Then I would distribute the 5 to both 200 and 10, and I'd get 1,000 plus 50, or 1,050. So that's how you could use the distributive property to break up a problem into a more manageable mental math problem. You can also use the distributive property to rewrite algebraic expressions or to simplify algebraic expressions. So for example, we have 8 plus 4n times 2. If I were to rewrite this expression to simplify, I would need to use the distributive property to distribute whatever is outside the parentheses to both parts inside the parentheses. And when I'm distributing, I'm multiplying. So the 2 is going to be multiplied by the 8. I keep the same operation and bring it down inside the parentheses, and then I'm going to multiply 2 times 4n. So I can keep simplifying this to be 2 times 8, which is 16. And then I could do 2 times 4, which is 8, times n, which is 8n. But then I need to look at it and see if I can simplify it anymore. Since I cannot, and the 8n is not a like term with the 16 because the 8n has a variable and the 16 does not, I cannot combine 8n and 16. So this is the most simplified that I can get. And that would be my final answer. Let's try another one. So for the next one, we're going to be distributing the -6 to each part of the parentheses by multiplying. So -6 times r plus -6 times 3g plus or minus -6 times t. And then we're going to go ahead and simplify. So when you're multiplying a number times a variable, you do not need to have a multiplication symbol. So we could write -6 times r as -6r. Same thing with the next one, -6 times 3g. I could write that as -18g. And then the last part, notice that you have minus a negative. That ends up being plus. Okay, and that would be 6 times t. So you'd have 6t. So if you look at this expression here, notice that each number has a different variable. So we can actually not combine any more than what we have right now. So our final answer would be negative 6r minus 18g plus, 6t. Now we're going to simplify expressions by combining like terms. Remember, like terms are terms that have to have the same variables and also have the same power. So if it's an exponent, it would need to have both of them be, let's say, x squared. You cannot combine x squared plus x cubed. So they would have to be the same power and the same variable. So, for example, if I were to simplify 6n minus 4n, since they both have the same variable, n, I can subtract 6 minus 4 and bring the n along to give me 2n. Another example, b squared plus 13b plus 13. This is the same as this. We have a b and then another b, but notice this has an exponent of 2, and if there is no exponent, like right here, then the exponent is considered to be a 1. So notice they have two different exponents. So we actually cannot combine the b squared with the 13b. And then we cannot combine either of those with the 13 without the variable because it does not have a variable. So this actually is considered already simplified. Okay, for the next one, notice that this expression has y's involved, but the y that has the 2 and the y that has the 8 both have exponents of 1. And since those are different exponents than the exponent here of 3, we cannot combine those two with the 4y cubed. So the 4y cubed is going to stay 4y cubed since we can't combine it. But the 2y minus the 8y we can combine because they have the same variable and they have the same exponent. So 2 minus 8, or negative 6, and we bring the y along. Then we have plus 5. Since that doesn't have a variable, we can't combine that with anything. So that would be our final answer. 4y cubed minus or plus negative 6y plus 5. So first we're going to write an algebraic expression. So we're going to translate the words into an algebraic expression. So I'm going to start by looking for some keywords. We have 5 times. Okay, if I'm going to do 5 times, and then I have the difference of q squared and r, I'm going to put that into parentheses because it's a grouping. So I have 5 times the difference of q squared and r. So q squared minus r. Then it says plus 8 times the sum of 3q and 2r. And again, that's a grouping of more than one term, and we're going to put that together in parentheses. So there would be my algebraic expression. So now I'm going to simplify the expression by using the distributive property first. I'm going to take the 5 and multiply by the q squared, and then subtract and multiply 5 times the r. So 5q squared minus 5r. Then I'm going to do the same thing with the 8. And really, when you're using different properties to simplify expressions, you always want to use the distributive property first if that's what you see. So you have 8 times 3q, 24q, plus 8 times 2r, 16r. Then I'm going to take a look and see if I have any like terms that I can combine. This has an r, and this has an r, so I can combine those two. But then if you look at the other two, one has a q squared, there's nothing else with a q, and one, oh, I'm sorry, I missed that completely. And another one has a q, so there's nothing left to combine with just a q. And remember, we can't combine the q squared with the q because they have different exponents. So the only thing we can combine is the 5r, or the negative 5r, plus 16r, which is going to give me positive 11r. And this would be as simplified as I can get.